Hello, ladies and gentlemen, and welcome back. Root Beer here with more of the 2015 Canadian Senior Math Contest. We're still in Part A. We're up to question number 5. So, question 5, it's a bit of a word problem here. It just stays on the page, though. In a psychology experiment, an image of a cat or an image of a dog is flashed briefly onto a screen, and then Anna is asked to guess whether the image showed is a cat or a dog. Alright. This process is repeated a large number of times with an equal number of images of cats and images of dogs shown. So, equal number there. So if this was done 20 times, 10 of those images are going to be cats, 10 of them are going to be dogs. If this was done 100 times, 50 of the images will be cats, 50 of the images will be dogs. Alright, that's important to know. We'll probably have an equation set up where like C is the number of images of cats equals D number of images of dogs. Maybe something like that. Alright, let's finish off the question here. If Anna is correct 95% of the time when she guessed dog, and 90% of the time when she guessed cat. So, if she guessed cat 10 times, 9 of those times it was a cat, and 1 of those times it was a dog. That's what they're saying here. Determine the ratio of the number of times she guessed dog to the number of times she guessed cat. Okay. Well, it's probably a good idea to give these values names. Number of times she guessed dog, let's call that little d. Number of times she guessed cat, let's call that little c. So ultimately we want d to c, that ratio. That's what we're looking for. And it's always important when you read a big word question like this to make sure you understand what's going on at each stage and to properly identify what they're asking for. Okay? It's not the ratio of number of images of cats to images of dogs. That's going to be a 1-to-1 ratio. It's number of times she guessed dog and number of times she guessed cat. That's the ratio we're looking for here. Okay? And I don't think we're given the total number of images or anything like that. So we probably can't get exact values of this, so we'll probably just be able to get number of times she guessed cat, little c, in terms of little d, the number of times she guessed dog, or something like that. That's the idea. But the first thing I'm going to do in a notepad is I'm going to give these names, because that's what I want to do. I want to make sure I know what I'm talking about. So, let d be the number of times she guessed dog. Not the number of times she saw a dog, not the number of times she saw a dog and was correct, although we are given information like that. So we want guessed cat. So we want, never forget, we want D to C. We want that ratio. Okay? D to C, right? We've got to double check that. Determine the ratio, the number of times she guessed dog to the number of times she guessed cat. All right. So, what have we got here? So, 90% of the time when she guessed cat, so 0.9 times C, it actually was a cat. That means 0.1 times C, it was a dog. Okay, so, alright, 90% of C, it was a cat. That means that 10%, the leftover percent, 10% of the time she guessed cat, she was wrong, so it must have been a dog. And I think we can do the same thing. I think it was 95% of the time she guessed D, she was right. It was a dog. So that means that 5% of the time, 5% of the time she guessed dog, it was, in fact, a cat. Okay. So, we use that piece of information. We're just sort of trying to translate and get as much information from the problem as we can. So, 95% of the time she guessed dog, she was right. So that means 5% of the time she guessed dog, she was wrong. So if it wasn't a dog, it must have been a cat. 90% of the time she guessed cat, she was right. So that means the remaining 10% she must have been wrong when she guessed cat. So that means it had to be a dog. Okay, so I think in terms of C and D, we can work out the number of images of cats and images of dogs, and we know that that number should be equal, and I think that will get us an equation relating little c to little d. Okay? I was going to introduce a capital C and a capital D for the actual number of images, but I don't think we need it at this point. Okay? I think we can get number of images of cats and number of images of dogs. So let's see what we can do. So I'm going to get my blue pen out just to make sure. So image was a cat, image was a cat. So we can work out the number of images that were cats. It's going to be 90% or 0.9 times C plus 5% or 0.05 D. And we don't care what she guessed. We just want to know, was the image actually a cat? And these are the two times it was a cat. 90% of the time when she guessed cat, it was a cat, and 5% of the time when she guessed dog, it was a cat. So now we're looking at the images that were dogs. Not that she guessed dog, but that it actually was a dog. So that's 10% of the time when she guessed cat, it actually was a dog. So that's 0.1c. And 95% of the time when she guessed dog, it was a dog. Okay? So these make sense, and we can equate them. So the number of images of a cat was equal to the number of images of a dog. That was the other piece of information they gave us. The experiment was repeated a number of times, and the same number of cat images as dog images was shown. And that means that these two values are equal. So we'll have one equation and two unknowns. That's not enough to solve, but that is enough to get a ratio, and that's all we were asked for. Okay? We can solve for C in terms of D or D in terms of C. Either way, let's bring the C's over to the other side. And the D's over onto the right side. .9 minus 0.1. Oops, sorry, that should be a C right there. 0.9 minus 0.1, that should be 0.8 times C. 0.95 minus 0.05, that's going to be 0.9 D. So let's say C is 0.9 over 0.8 D. Well, that's going to be 9 over 8 D. So C, the value of C, the number of times she guessed cat, is 9/8 as large as D, the number of times she guessed dog. So if we plug that into our ratio, we get D to C is the same as D to 9/8 of C. Or sorry, 9/8 of D. Okay, if we want a ratio, well, we can multiply through the same. So let's multiply by 8. So 8D to 9D. And then we can divide through by D, whatever it is, and get 8 to 9. So we make a final little statement here. The ratio of, you could easily get confused here, and probably a lot of people put 9 to 8, I would guess, but I think we've done it carefully enough that it is 8 to 9. So the ratio of number of dog guesses to number of cat guesses is 8 to 9. Okay. So 8 to 9 would be our final answer. We put that in the little box that is provided in the answer booklet. Let's just go through and double check. So we identified what we wanted, D to C, and then we started getting things in terms of D and C. Okay, we were given information about the number of times she was correct when she guessed something. And that led us to these two equations, which had to be equal. We rearranged them, and we solved for C in terms of D. We could very easily have solved for D in terms of C, that would have been fine as well, and we would have gotten 8 over 9c to c, which we multiply by 9 on both sides, we get 8 to 9c, or 8c to 9c. We still get 8 to 9 there. So I'm really confident in our 8 to 9 answer. Okay. So not bad at all. That was question number 5. In the next video, we're going to take a look at question number 6, the very last question in part A. So hopefully you'll join me for that. And as always, thank you guys so much for watching.